Faculty of Earth Science. So I'm going to show you AAS instrument in our lab. Let's go.
Do you know heavy metal can cause contamination in soil, water, and plant? A study by Jindy and colleagues in 2020 analyzed soil samples from Iraq's Dhaka district. They found elevated levels of lead and zinc. Meanwhile, a 2024 study by Nugraha et al. Revealed that eggplant samples from Pontianak City, Indonesia contained lead and cadmium levels exceeding food safety standards, a stark reminder of the dangers of consuming contaminated produce. In response to these threats, scientists developed a cutting-edge magnetic solid phase extraction method using zinc oxide and iron oxide nanoparticles. This innovative technique, highlighted by Korkmaz et al. In 2025, is capable of identifying and extracting lead and cadmium from water samples. Among these metals, lead remains a key focus due to its toxicity, mobility, and environmental persistence.
For plants, according to Nugraha et al. 2024, eggplants were collected from markets in Pontianak. The samples were washed, chopped, ground, and sieved. Then, a digestion process was carried out using a mixture of nitric acid and hydrogen peroxide in a 4:1 ratio. This step breaks down organic matter and releases lead into the solution. The digested sample was filtered, diluted, and then analyzed using AAS. For soil, based on Jindy et al. 2020, surface soil at 0 to 20 cm depth was collected from both agricultural and urban areas. Subsamples were combined into composite, then air-dry and sieved. 1 gram of soil was digested using concentrated nitric acid at 100 degrees Celsius for 1 hour. After digestion, the sample was filtered, diluted, and tested by AAS.
Press extraction MSPE, which nanoparticles to extract PB2 and CD2 ions from water sample adjusted to pH 6. And the nanoparticles were magnetically sputtered, eluted with nitric acid, and analyzed using flame atomic absorption spectrometry AAS.
3 journals utilize atomic absorption spectrophotometry AAS for analysis. The first journal focused on analyzing purple eggplant samples from Pontianak, which were prepared, touch, drying, crushing, and dissolving in acid before AAS analysis. It is from Nugraha et al. 2024. The second journal synthesized ZNO or Fe3O4 nanoparticle for the removal of lead and cadmium from water. The metals were spread magnetically, redissolved, and quantified using flame AAS. It is from Korkmaz et al. 2025.
Lastly, soil sample was collected from 26 locations, air-dry and oven-dry at 105 degrees Celsius for 24 hours. The sample were then crushed, sieved and ground into fine powder. 1 gram of each sample was dissolved in deionized water to extract the heavy metals. The concentration of PB and other metals was analyzed using AAS and calibration curve.
Okay, I want to present about analysis technique using the atomic absorption spectrophotometry AAS. All 3 studies which investigate lead contamination in plant, water and soil were analyzed using atomic absorption spectrophotometry AAS. Okay, AAS instruments are the primary analytical technique to detect and quantify lead concentration due to their high sensitivity and specificity. Okay, if the greater if the greater absorption, the higher concentration of lead will be in the sample.
Next, for the plant sample, the material were first washed, dry and ground into powder. Then they was decayed using nitric and perchloric acid to break down organic matter, releasing the matter into solution for analysis. In the water sample, the sample were either filtered or decayed with nitric acid to ensure all the lead was in dissolved form. After that, they were analyzed directly using AAS to measure lead concentrations. For soil sample, the soil was dry and cleaned to remove debris and degassed using aquareagent, a mix of hydrochloric and nitric acid to extract the lead from the solid first. In conclusion, other sample preparation differ by material type. AAS provide a consistent and reliable method for detecting and quantifying lead contamination across all environmental samples.
For data and result analysis, for Korimas et al. 2025 using solid waste extracting ZNO and ferrum particles, excellent recovery value of 99.292 until 101% in the case of PB and 99.6 until 100% in the case of CD. Low detection limit of 2.36 micrograms per liter in the case of PB and 7.86 micrograms per liter in the case of CD. For Negara et al. 2024, the content of PB and CD in its plant at the Pontianak market in Indonesia. The CD range between 0.056 micrograms per liter and 0.0986 micrograms per liter of CD, and PB concentration at the safe limit on 0.0 micrograms per liter in the two samples, implying they are polluted agriculture input and of the urban pollution.
Soil samples from Zakko, Iraq were tested for heavy metals. Lead was found between 0.541 and 4.339 milligrams per liter, and cadmium was estimated. Other metals like zinc, copper, and nickel were within safe limits, so the soil still looks suitable for farming. Among soil, water, and plant samples, plants had the highest lead level, which is concerning. This suggests they absorb lead easily, likely through their roots. Soil was less contaminated, possibly due to differences of how metal move and interact. They use magnetic solid phase extraction, an effective method for accurate result. Overall, it shows how environmental and human factors affect contamination in soil, water, and food.
Okay, so the conclusion is comparative evaluation of lead pollution in the soil, water, and plant matrices using atomic absorption spectrophotometry (AAS) recognize the differential environmental pollution levels and effectiveness of specially formulated sample preparation protocols. Among the studies presented, plant specimens, specifically eggplants from Pontianak, Indonesia, had the highest and most critical lead concentrations, surpassing food safety requirements and posing immediate threats to human health. Contrarily, Iraqi water samples and soil samples with aqueous samples after sophisticated magnetic solid phase extraction techniques had lead levels within or near acceptable levels, reflecting diversified metal mobility and bioavailability across environmental media.